We can go over more like that in class. Okay, number 7. So think about domain and range. So if I look at 7, I'm pretty sure these should have been arrows. Doesn't look like they printed very well. But if we're looking at domain, we're talking about left to right. These will go forever, all the way left, forever, forever, all the way right, forever, forever, forever. Okay, so that's all real numbers. But if you look at the range, there's a clear high and a clear low. Clear high and a clear low of this graph. Okay, and what I didn't do is read the problem. It says it wants interval notation. Okay, so instead of all real numbers, all the way left is negative infinity, and all the way right is infinity. So you may want to write that here. If you're going to get all real numbers, your interval notation is negative infinity to infinity, okay? And if you have a greater than something, it's going to be the number to infinity, and a less than, it'll be negative infinity to the number, okay? But for this, and you'll see that come up, but for this, let's just talk about this graph. All right, so there's a very clear high and a low value of where y takes up. So -5 and 5. That's your range. It's between -5 and 5. So if you had an inequality, it would look like this, okay? But it wants interval notation. So our interval notation would be closed, so bracket, -5 to 5. So that means this graph takes up all the values from -5 to 5 on the y-axis. That's what that means. All right, let's look at 8. It's domain. So if you look very closely, there is a hole at -1 on the x, at -1 on the x, and at -3 on the y. Okay, so basically, like we did before, see how the arrows go on forever and the line goes all the way left and right forever, also all the way up and down forever? It's going to be the same thing as one of the other ones we talked about. It's going to be x cannot be -1 because there's a hole in the graph. Right? Before there was an asymptote, now there's a hole. X still can't be that. And then y can't be at -3, the y value of that hole. So that hole's at -1, -3, okay? So the x can't be here and the y can't be here. We've just got to turn that into interval notation. All right, so x cannot be -1. So that means from -infinity all the way up to this point, it can be included. Then there's a gap, so union this point all the way to infinity, okay? So our domain's going to be -infinity, comma -1, closed, because this is open, union -1 infinity. So that literally means everywhere except for -1, because they're open on both sides. And like the same idea with the y, so there's a value from -infinity until you hit -3, union, it picks back up at -3 and goes to infinity. Okay? Okay, ooh, stop shaking. All right, number 9. Okay, yeah, that's fine. All right, number 9, there's a clear point on our x. If you're looking at x, it clearly stops right here. And that's at x equals 0. And the graph does not take up the right side of it at all. Okay, so if you were doing interval or inequality, the entire graph is taking up the left side of 0, right? So less than 0. And then at 0, there's definitely a point included. So x is less than or equal to 0, which would mean, like on a number line, -infinity to 0. So that's your domain here. We're going to include the 0 because part of the graph is on 0. There wasn't a hole, so it's definitely included. All right, now range cares about up and down. So this graph, if you extend it, is going all the way up forever, and on the bottom would go all the way down forever. So our range is definitely all real numbers, okay? All right, next, number 10. All right, it's a little hard to see this graph. Okay, but it's clearly, it's asymptotic right here, meaning it's not crossing the graph at 1, 2, 3, 4, 5, at -5 on the y, okay? But it's not asymptotic here. If you watched before, or if you look closely before I drew this, it's getting bigger and bigger and bigger. Okay, it's only asymptotic right here, and that's probably the harder things to see with the graphs. But it crossed over, it kept crossing over and getting bigger and bigger, any line that you tried to draw. This one is not crossing over -5 horizontally. Okay, so let's talk about what that means for the domain and range. So domain, we care about left to right, so this would keep going all the way left, and as this gets bigger, 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 it'll keep going all the way right. That domain is all real numbers, which is -infinity to infinity in interval notation. All right, so for range, we care about up and down. This graph is clearly approaching -5 and then going up from there. So we have -5 and we know it's going up to infinity. Now, am I going to include that with a bracket or is it open with a parentheses? Okay. Well, that's what asymptotic behavior means. It's approaching -5, but it's never getting there. So it needs to be open. Open. All right, number 11. So again, we have an asymptote. As you can see, these are approaching -1, but they're not quite getting there. And in this case, they're approaching -1 on x. Okay, so that's going to affect our domain. All right, so from left to right, this is going all the way left forever and all the way right forever. We just don't have an x value at -1. So that again is just like 8, actually, exactly the same. So -infinity to -1 union -1 comma infinity. So that graph takes up all those values except for -1, and we can't include it, so open parentheses. All right, the range should be pretty obvious here because this is pointing downward forever and the other part of the graph is pointing upward forever. So that one, the range is going to be -infinity to infinity, all real numbers. Okay, 12. And you can pause these and try them on your own and then see if you get them right if you want. So 12 is different than really any of the other ones because we don't have arrows on any side, okay? So this is an endpoint that's open and this is an endpoint that's closed. So when we talk about the domain, the leftmost point is here and it's open, and the rightmost point is here and it's closed. So how could I write that in an interval notation? Well, that's at -1, 2, 3, 4. So -4, open circle, and my graph goes to 1, closed. Okay? All right, and then the range, well, there's clearly we care about low and high for range. So there's clearly a lowest point of the graph and clearly a highest point of the graph. So the lowest point is down here and the highest point is up here. They both have solid either points or continuous functions, so they're both going to get a bracket at their value. Okay, so down here, -1, 2, 3, 4, 5, 6, 7. That's my lowest point. That's part of the continuous function, so it definitely gets a bracket, and the highest point is at 2. And that's also gets a bracket because it's closed. Okay? Okay, so I'm just sneaking this in here really quickly, is determining whether functions or relations are functions or not. Okay, and that'll be it. So a function is a special type of relationship in which each element in the domain is paired with exactly one element of the range. Okay, so one and one only. You might have heard this called 1 to 1. So one domain to one range only. All right, so what does that look like in a table? All we care about here is really that the x values don't repeat when you're looking for a table or a mapping, okay? And a mapping would obviously be there's not repeating lines or repeating maps. Okay, but for the table, if you look at the x values, I have -3, -1, 2, 5. Those are all different values. So this would be, yes, this is a function, okay, for 13. For 14, even though I have 9, 0, and 4, you can't have repeating mappings, okay? So if I look at 9, it's going to -2, and it's also going to 5. So if I had like an XY table, I would have 9 twice, okay? And that would be not a function. It does not have one x for every one y. There's 2 x's, okay? So not or no, not a function. Okay, and then 15, that's pretty simple to check again because you're just looking at the x values and making sure they don't repeat. Those don't, so yes, we have a function here. Okay, yes, function. All right, finally, last idea here is vertical line test. So when you're given a mapping, a table or a list, that's different than if you're given a graph, okay? So vertical line test is when you're given a graph. So for this, you cannot have your vertical line hit more than once. Cannot hit more than once. If it does, then you don't have a function. Okay, so that means on 16, if I chose any vertical line anywhere infinitely, all of them, not just on the even squares, anywhere, it's only hitting the function, which is the graph thing, the graphed part, it's only hitting that once, okay? So yes, this is a function. All right, 17, if I draw my vertical line at 0, okay, that's only hitting once, but it needs to be for any vertical line anywhere. And you can see any of the other ones to the right of 0 are hitting twice. So, no. All right, and 16, okay, so let's see. This may be different. This is kind of like taking you up to pre-calculus versus algebra 2. So here I'm hitting only once. That's all cool. I know I'm hitting only once over here. All right, but what's happening in the middle? Well, we have an asymptote, so is it ever going to hit those values? Hit more than once, like on the left and on the right? It's not, because this is just approaching the asymptote. It never gets there. So it's still gonna pass the vertical line test at the asymptote, okay? Because there will never technically be a value that is shared. So that's a yes. All right, and that's it for lesson 1.